In this tutorial, we're going to look at the Chatelier's principle, which allows us to predict a change in equilibrium when there's a change in conditions, and where we can predict in which direction, which side of the equation that movement will occur. Okay, now the Chatelier's principle states that the equilibrium will shift to counteract any change you make to the system. Okay, now these changes can either be in the concentration, temperature, volume, or pressure. So let's just dive right in with a few examples. Let's start off with volume. Okay, let's take an example, equilibrium equation. Let's just go CO2 plus hydrogen goes to, carbon monoxide plus hydrogen goes to methanol. So if we just write that equation out, so that's carbon monoxide plus 2 molecular hydrogen, and it's an equilibrium, so remember we've got the double arrow, and that goes to methanol, which is CH3OH. Okay, now if we were to decrease the volume, okay, so the volume is going to go down, then then the system will move to create more molecules to stabilize the pressure. Okay, so if the volume were to increase, the reaction would move to the side which contained more molecules. So an increase would make an increase in volume would make the equilibrium move to the left in this example, and a decrease would make it move in a direction to the smallest amount of molecules. Okay, so an increase in volume will move in the direction of most molecules, a decrease in volume will move to the direction of least molecules. Okay, now we can use the same example for pressure. So, okay, an increase in pressure the equilibrium will move to counteract that change. So we'd want to decrease the pressure again, and to decrease the pressure, we'd want to move to the side with least molecules, and vice versa. If the pressure were to be decreased, then it would move to the equilibrium would want to move to increase the pressure again, so it would move to the side with the most molecules. Okay, so if we just get rid of this, then we can move on to temperature. Okay, so moving on to temperature. If we would, let's just take an example of the creation of ammonia from nitrogen and hydrogen. So we've got nitrogen plus 3 hydrogen. Again, it's an equilibrium, so it's double arrow, goes to ammonia. Okay, and this is a exothermic reaction, so we've got empathy change of negative 92 kilojoules per mole. Okay, so now let's just say if we increase the temperature, if we think about this, the Chatelier's principle states that whatever change we do to the system, the equilibrium will change to counter that change, will move to counter that change. So if we increase the temperature, so this reaction is going to want to decrease the temperature of the system. So it's going to want to move in the endothermic reaction, in the endothermic direction. And since it's exothermic to the right, in the forward direction, it will move to the reverse direction, which is the endothermic direction. And again, vice versa, if we decrease the temperature, it's going to want to move in the forward direction where the reaction releases heat, thus undoing the change of the decrease in temperature of the system. Okay. Now if we just take a different example for concentration, so if we just delete all of this, Uh-huh. Delete. Yep, delete. Okay. Now then, the concentration. Um, so changing concentration. Um, so let's just give an example here of the creation of methanol. Again, we'll go back to our first example. So carbon monoxide plus 2 molecular hydrogens uh, goes to methanol. Okay, now if we were to increase the concentration of the carbon monoxide, there would be an increase in so we increase the concentration of carbon monoxide. Okay, that's going to move to I can't write neatly. Um, right, okay, carbon monoxide. That's going to move the equilibrium to more of the products, um, because if we increase that, the equilibrium is going to move to decrease it to balance it again. The only way to do that is to make more of the products. And again, if we increase um, the carbon monoxide, the methanol, again, it's going to want to move in that direction. And it's the opposite for a decrease in pressure. Hope you found this tutorial useful. If you have, don't forget to give the thumbs up below. And if you've got any questions, just put them in the comments box. Thanks for watching.